Seasons change even on Mars. A look at how NASA's explorers study the weather and cope with change, especially in the case of the Ingenuity helicopter, which now has to fly in a thinner atmosphere. This visualization, known as NASA's EYES, shows where the agency's 2 rovers and lander are touring the planet. For most of them, measuring the weather is a key part of their job. It's early summer in Jezero Crater, where NASA's Perseverance rover and the Ingenuity helicopter are exploring the South Sator region. Perseverance uses its Mars Environmental Dynamics Analyzer, or MEDA, to measure temperature, humidity, wind speed, and direction. These wind sensors also measure the amount and size of dust particles in the atmosphere, helping scientists understand the dust cycle and its impact on weather. MEDA also provides the Ingenuity helicopter with critical pre-flight weather forecasts. Recently, warmer temperatures and a thinning atmosphere have made it more difficult for the helicopter to generate enough lift to fly. Its rotors had to spin faster than they had in previous flights, roughly 2,700 revolutions a minute. In the southern hemisphere, where the Curiosity rover is driving in Gale Crater, it's early winter. The Rover Environmental Monitoring Station, REMS, provides daily weather reports and takes regular dust surveys to measure seasonal changes over time. The InSight lander is focused on what's happening below ground. In September, it measured one of the biggest, longest-lasting Marsquakes ever detected. Seismic waves from the magnitude 4.2 shook InSight for nearly an hour and a half. Finally, the fleet of orbiters, including Odyssey, the Mars Reconnaissance Orbiter, and MAVEN, helps scientists understand the scope and scale of storms from above. MRO produces a daily global weather map and provides us with amazing images. If you're interested in dunes on other worlds, check out these recent photos.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system is to spin very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight test at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Now, it has been a dream of scientists for generations to bring back samples from the surface of Mars. Now, right now, the Mars 2020 rover mission is laying the groundwork for that to happen. And that's why I'm in the In Situ Instrument Laboratory with Jessica Samuels, and she's here to tell us what's going on here.
Well, we use this facility to develop and design our hardware and software systems for our Mars mission.
And how does the sampling system work?
So we have a drill on the end of our robotic arm, and as we are drilling the surface of Mars, we will be collecting pieces of Mars into the sample tube at that time. We'll then transfer that sample tube into the inside of the rover and then seal it for storage as we continue to explore the surface. After we've collected a diverse set of samples, we will drop them off onto the surface and then have them there for our future sample return mission to continue.
Well, I know you have some tests to keep doing, and I'm actually going to go check out the next phase at a different lab. We're in a testing lab affectionately known as the Sandbox, and I'm here with Austin Nicholas. Now, can you explain how we are going to bring back samples from Mars?
So starting from after 2020 has deposited tubes on the surface, there are 2 more missions to go in bringing the tubes back to Earth. The first is a lander mission. It carries 3 major elements. a sample fetch rover, and a sample transfer arm that lets you transfer the samples from the fetch rover into the rocket. And a Mars ascent vehicle, which is a rocket that brings the samples from Mars into space. Meanwhile, the orbiter has also launched from Earth in 2026 and is making its way towards Mars, and it'll be in position by the time the rocket's fully loaded. The orbiter will then go to the sample container that the rocket's put into space and then capture it, ultimately bringing them to Earth in 2031.
That sounds complicated.
It is complicated, but fortunately we're not doing it alone. So we have a great partnership with the European Space Agency, and they're providing some major pieces of this mission. Within NASA, we've actually got a number of centers working on all of the different pieces. So we're partnering with Marshall Space Flight Center for the Mars Ascent Vehicle, Langley and Ames for the Earth Entry Vehicle, Glenn for the sample fetch rover wheels, and we're partnering with Goddard for the orbiter payload. And so there's really it's a whole NASA effort to get Mars sample return done.
Sounds like there is a lot of work to be done, but this all kicks off with the launch of Mars 2020 this summer in Cape Canaveral, Florida. And there's lots of excitement here as we get ready to make history.